During 300 BC, a mathematician and geometer known as Menaechmus solved the problem of doubling the cube, and he discovered conics, including the ellipse, parabola, and hyperbola. However, during this time, these terms were commonly referred to as a parabola, a section of a right-angled cone, a hyperbola, a section of an obtuse angled cone, and an ellipse, a section of an acute angled cone. The problem of doubling the cube was solved by solving for the points at which two parabolas intersect. Menaechmus found the conics by the intersection of cones and planes perpendicular to the axis of the symmetry of the cone. His discovery was later researched and investigated by mathematicians like Archimedes and Apollonius.
Archimedes of Syracuse, an ancient Greek mathematician and physicist, is generally considered one of the greatest mathematicians of all time. Archimedes focused on what was already established in the development of more challenging theorems rather than developing a complete system for conics. It is rumored that Archimedes presented the names of the various conic sections, and Apollonius later built off of his work and developed the theorems for conics. Some of Archimedes' accomplishments include discovering theorems for finding the area of a circle, the surface area and volume of a sphere, and the area underneath the parabola's arc. Apollonius of Perga, who lived from 262 to 190 BC, greatly contributed to the study of geometrics, specifically conics. In fact, he is known as the Great Geometer. His theorems focused on how the different types of conics are formed and their standard equations. His work influenced many later scholars and worked with friendly rivals such as Euclid and Archimedes. He is most famously known for giving a name to the ellipse, parabola, hyperbola. In his work, he demonstrated that it isn't necessary for the plane that intersects the cone to be perpendicular to it. Also, a cone could be either scalene or oblique. Furthermore, he introduced the idea that the same cone could be used to form all three conic sections. He also wrote an 8-long book series called Conics.
Omar Khayyam, who lived from 1048 to 1131, was the first Persian mathematician, astronomer, and poet who, like most artists and scientists at the time, worked under the help of the Sultan's power and money. Khayyam used conics to solve cubic formulas by using a rectangular hyperbola and circle. He was able to recognize 13 different forms of cubic formulas and wrote about them in his book, Treatise on Demonstration of Problems of Algebra. It held classifications of these with geometric solutions using intersecting conic sections. He also shared the realization that cubics can have more than one solution.